This video is on arithmetic sequences. So an arithmetic sequence is when the difference between each term is constant. So here we have a few examples. So this here is an arithmetic sequence because the difference between each term is +2 like this. And for every single sequence, it goes up by +2 like this. This is an arithmetic sequence because it keeps going up by a half, a plus a half, like this. And this here is also an arithmetic sequence because the difference between each term is -3. For every single term, it keeps going down by -3. It could be negative as well. Now, something that comes up a lot in sequences is the term un, like this, where un is the nth term. You may have heard of the nth term before. Un is basically just a shorthand way of writing it, where n is what term in the sequence we're talking about. So for this first sequence here, if we wanted to find u1 here, so that means n is equal to 1, so that means we need to find the first term. So therefore this is just going to be 2 here, like this. So this is going to be u1. For the second sequence, if we wanted to find u3, for example, this would be the third term, so it'd be 1, 2, 3 like this. So this would be u3 as it's the third term. It'd be 7/2. And for this sequence, if we wanted to find u4, this would be the fourth term in the sequence. So it'd be 1, 2, 3, 4. So therefore it would be this here. So u4 for this sequence would be equal to -7. Now, for an arithmetic sequence, there is a formula for finding un for any sequence and for any value of n, and it is un is equal to a plus n minus 1 d, like this, where a is the first term. Another way you could say is is u1, like this. So this here would be the first term for this sequence, and d here, d is the common difference. And this is what we talked about already. So for this first sequence, it would be the +2 here. It's whatever the common difference is between each term. And then n is what term we're talking about. So n is going to be the nth term. It's going to be this value of n here. So 1, 2, 3, whatever term we're talking about in the sequence. So for example, let's say that we wanted to find u5 for this first sequence here. We wanted to find u5. So this would be equal to, so we have to use this formula here. So a is going to be this first term here. So it's going to be 2 plus, and then it's going to be n minus 1, and n is going to be 5. So it's going to be 5 minus 1, like this. And then d is 2, like this. So we usually just put this in a bracket as well, and like this. And we can simplify this. So it's going to be 2 plus, and 5 minus 1 is 4. So it's going to be 4, 2 like this, which is going to be equal to 2 plus 8, which is going to be equal to 10. So u5 is equal to 10, and we can see this if we just extend the sequence. So 2, 4, 6, 8. So if we plus 2 to 8, it would be equal to 10, like this. So we can see that u5 would be equal to 10. For this sequence here, if we wanted to find u6, it would be equal to, okay, so a is equal to 5/2. And it's going to be plus n minus 1, and n is 6. It's going to be 6 minus 1, and this is going to be times by d, which is equal to a half, like this. We can simplify this to 5/2 plus, and then it's going to be 5 times a half, which is going to be equal to 5/2 plus 5/2 like this, which is just going to be equal to 5. So u6 is equal to 5. And we can see this again if we extended this sequence like this. So it goes 3, 7/2, 4. So if we plus another half, it would be equal to 9/2. And then if we plus another half, it would be equal to 5, like this. So we can see that u6 would be equal to 5 here. Let's do one more example for this sequence here. And let's say that we need to find u7. So this would be equal to, so a is equal to 2, so it's going to be 2 plus, and then n minus 1, because we're trying to find u7, is going to be 7 minus 1, and then d is going to be -3, like this. We can simplify this to 2 plus 6 times -3, which is equal to 2 minus 18, which is equal to minus 16. So u7 for this sequence, the 7th term, will be equal to minus 16. But n could be anything, no matter how high, we can find any term. So here's an example question about arithmetic sequences. So for part A, we need to find an expression for un like this. So remember that un is equal to a plus n minus 1 d like this, where a is the first term and d is the constant difference between all of the terms. So therefore a is going to be equal to the first term, and we can see that the first term here is 11 like this, and then d is going to be the constant difference between each term. So how much do these terms go up by each time? And we can see that each time it goes up by plus 9, and it's a constant difference in arithmetic sequence because for every single one it goes up by plus 9 like this. So therefore this is going to be equal to 9. So therefore we can find an expression for un in general. We can say that un is equal to a, which is 11, plus, and then n minus 1, because we're just doing it generally for n, we're doing it in terms of n, and then d, which is 9, like this. We can simplify this to 11 plus, and we'll just write it like 9 of n minus 1, and then we can expand the brackets and simplify it to do 11 plus 9n minus 9, which is equal to 9n, and then 11 minus 9 is equal to plus 2. So un is equal to 9n plus 2. And then for part B, we need to find the 22nd term in the sequence. So this is going to be when n is equal to 22, because it's the nth term and we need to find the 22nd term. So therefore, we're just going to sub 22 into here. So it's going to be u22, because that's what we're trying to find. u22 is equal to 922 plus 2, which is equal to, if you put it into a calculator, 200. So the 22nd term in the sequence is equal to 200. That's what u22 is equal to. And then for part C, we need to find the value of n for which un is equal to 677. So therefore we need to find when 9n plus 2 is equal to 677, and therefore we just need to rearrange in order to find the value of n. So therefore we move the plus 2 onto the other side to do 9n is equal to 675. So therefore n is going to be equal to 675 divided by 9, which if you put into a calculator is equal to 75. So therefore u75 is equal to 677 up here. Now, there are two different terms in this chapter, sequences and series. So a sequence is what we've already seen like this up here. A series is the exact same thing, but all of the numbers are added together like this. So these two are the same, but one's a sequence and one's a series. So an arithmetic series follows the same rules as an arithmetic sequence, it's just all of the numbers added together instead. So here's two of the examples that we talked about before, but they're now series instead of sequences. Now another term when we talk about series is Sn, where Sn is the first n terms of a series added together, where n here is whatever the n is here in Sn. So for example, let's say that we need to find S2. This would be equal to the first two terms added together. So it'd be equal to 2 plus 4, which is just equal to 6. So S2 is equal to 6. If we need to find S4 for this series here, this would be the first 4 terms added together. So it'd be equal to 5 over 2 plus 3 plus 7 over 2 plus 4, which is equal to 5 over 2 plus 7 over 2 is equal to 6, and then 3 plus 4 is equal to 7, so 6 plus 7 is equal to 13. So S4 is equal to 13 like this. Now, like UN, there is a formula that allows us to find Sn for any arithmetic series and for any value of n, and this is where Sn is equal to n over 2 of 2a inside the brackets plus n minus 1 and then d like this, and then close brackets. So again, this is the same parameters we talked about in UN, where a is the first term, d is the common difference, and n is the nth term, whatever the n is in the nth term. So for example, for this first series here, let's say that we need to find S9. Well, we can use this formula here, where n is equal to 9, so it's going to be 9 over 2, and then it's going to be 2a, and we know that a is the first term, and it's equal to 2, so it's going to be 2 times 2 plus n minus 1, so it's going to be 9 minus 1, and then d, we talked about before, is going to be 2, because it's plus 2 between each term. So it's going to be 2 like this, and then close bracket. And if we put this into a calculator, this is equal to 90. So S9, the first 9 terms added together, is equal to 90. If we need to find S13, again, we can use this formula here. So this is going to be equal to 13 over 2. 2 times a, and a is 5 over 2. And then plus n minus 1, so it's going to be 13 minus 1. And then d is going to be equal to a half, like this, and then close brackets. And if you put this into a calculator, this is equal to 143 over 2. So S13, the first 13 terms added together, is equal to 143 over 2, like this. Now, there is another formula for figuring out Sn. And this is where Sn is equal to n over 2 of a plus L instead, where L is equal to the last term in the series, or it could be like the nth term in the series, whatever the nth term is that we're going up to. So for example, let's say that for this series here, we needed to find S5 like this. Well, we could use this formula here, so it's going to be n over 2, so it's going to be 5 over 2, and then a is equal to 5 over 2, so it's going to be 5 over 2, plus the last term, which is equal to 9 over 2, because we're going to S5, so we're going up to the 5th term here, like this, so this is going to be 9 over 2, and if you put this into a calculator, this is equal to 35 over 2. So S5 is equal to 35 over 2. So we can use this formula. Now, 99% of the time, we don't use this formula though, and we use this formula instead. And the reason is because a lot of the time questions will ask us something like S13, and we can't use this formula for S13 because we don't know what the 13th term here, it doesn't go this far. So we'd actually have to go and figure it out, which is a lot of work. So instead, we just use this formula here. So 99% of the time we don't use this formula. Now both of these formulas are actually given in the formula booklet, so that's really nice, but 99% of the time we use this formula here. So here's an example question on arithmetic series. So for part A, we need to find S12, and I've given you the formula for Sn because, as I said, this is given to you in the formula booklet, so you don't need to remember it. It's given to you in the exam. We just need to sub in the values of A, D, and N. So A is the first term, and it tells us that the first term is minus 81, and then D is going to be equal to, so it's told there's a common difference between consecutive terms of 8, so therefore D is going to be equal to 8, and N is going to be equal to 12, so figuring out S12. So therefore S12 is equal to, and then we just sub in the value, so it's going to be 12 over 2, and then 2 times A, which is minus 81, plus N minus 1, so 12 minus 1, times D, which is 8, and if you put that all into a calculator, it's equal to minus 444. So S12 is equal to minus 444. So for part B, we need to find the least amount of terms the series needs to have for the sum of the terms to be positive. So what this question is actually asking is we need to find the smallest value of n, because we need to find the least amount of terms. So the smallest value of n for which Sn is positive. So therefore Sn is bigger than 0. So therefore as Sn is equal to this, therefore it's going to be when this is bigger than 0. So when n over 2 of 2a, and we know that a is equal to minus 81, so 2 of minus 81 plus n minus 1, and then d is 8, and when this is bigger than 0. This is just an inequality that we can solve. First, I'm going to times both sides by 2 here to get rid of the 2 in the denominator. So we can do this because this side is 0. So it's going to be n of, and then 2 times minus 81 is minus 162. Plus, I'm going to move the 8 onto the front here to make it a bit more neat. So it's going to be 8 of n minus 1 here. When this is bigger than 0, expand the bracket to get n of minus 162 plus 8n minus 8, and when this is bigger than 0, and then simplify this by doing n of 8n minus 170, and when this is bigger than 0. So this is an inequality, and you might be tempted at this point to say we can divide both sides by n in order to get rid of this n at the front. And you can't do that for two reasons. One, n could be 0, and remember you can't divide by 0, that just makes everything a mess. Or n could be negative, and if n is negative, remember that when you divide an inequality by both sides of an inequality by a negative number, it flips the sign of the inequality. But we don't know if n is negative, so therefore we don't know if it's flipped or not. It could be one of the two, so therefore we can't divide by n, as it could be a negative number. Now, you might say at this point that n can't be 0 or a negative number, because n can't be 0 because you can't have a 0th term, and n can't be a negative number because you can't have a negative term. You can't have like the minus 1th term or something like that. And the answer to that is this here is just maths. This here is just an inequality, and this inequality doesn't care about the context of the question. It doesn't care about the fact that n is what term it is in the series. This is just an inequality to the point where for this inequality, this n here, it could be 0 or it could be minus 1, despite the fact for the context of the question it can't. So we just need to go forward with this inequality as just solving it as maths, where this could be 0 or it could be minus 1, and then if we get a value out that is 0 or a negative number, then what we just do is say that that can't be the answer and only use the answers that could be values of n. So we have to go forward without dividing by n, so therefore this is going to be a quadratic inequality, where if we expand the brackets, it's going to be 8n squared minus 170n is bigger than 0. And then what we need to do is solve this quadratic inequality. We talked about how to solve quadratic inequalities in the quadratic inequalities video. I'm not going to go through a thorough explanation of how to do it here. I'm just going to do it, so go back to that video if you need to. First, you replace this inequality sign with an equal sign, so it's going to be 8n squared minus 170n is equal to 0, and then we need to factorize this. We need to solve this quadratic equation. We've already factorized it down here. To take out n, to do n of 8n minus 170 is equal to 0, so therefore n is going to be equal to 0, and 8n minus 170 is going to be equal to 0, so therefore 8n is equal to 170, so therefore n is going to be equal to 170 divided by 8, which is going to be, if you put into a calculator, 21.25. So n is equal to 0 and n is equal to 21.25, and then we sketch a quick graph like this, where this is y and this is, technically this is n because we've used n here instead of x. You might just want to write x here because it's more familiar with x, y, but this is technically n here. If you really wanted to, you could replace both these n values with x when solving the equation, if that makes it easier for you. And then we need to sketch this quadratic here, and we know that the roots are at 0 and 21.25, so it will look something like this here, where this root here is 0 and this root is 21.25, like this. And therefore we need to find when this inequality is positive and bigger than 0, and this is here and here. This is the only point where n is where it's negative and is less than 0. So therefore this inequality is going to be here when n is less than 0, and here when n is bigger than the root 21.25. We can completely ignore this here because this is when n is less than 0, and we talked about that n can't be less than 0 as a solution because we're talking about it in terms of a series, so we can't have a negative n, so therefore n has to be bigger than 21.25. So therefore the smallest value that n can be, as n can't be a fraction or 21.25, something like that, as you can't have a fraction of a term, n is equal to 22. That is the smallest amount of terms which is going to be positive. So therefore the least amount of terms the series needs to have for the sum of the terms to be positive is going to be 22 terms. N is equal to 22, so it's 22 terms, and that's the final answer. Now, you may have noticed that if we did just divide by n here, we would have actually got this answer here still with n is equal to 22 and 22 terms. However, if you did this in the exam, I wouldn't be surprised if you lost a mark, because this technically, mathematically, you can't divide by n, as it could be equal to 0 or it could be negative. So I would go through not dividing by n, solving the quadratic inequality, and then doing this, acknowledging that it can't be less than 0. So this can't be a solution. Now, the spec specifically says that you could be asked to prove the formula for Sn for an arithmetic series, and there is a very specific method to do this, and I would advise you just to learn it. So the question is that we need to prove that some of the first n terms in arithmetic series, so Sn, is this formula here, which of course we already know it's in the formula booklet, but we need to actually prove it. Okay, so to do this, firstly, let's write out what Sn actually is. So Sn is all of the first n terms added together. So let's actually write this out. So it's going to be the first term, which is a, plus the second term, which is a plus d. I've put brackets around it to show that this is the second term, where we've added 1d here. And then the third term is a plus 2d, like this. And this will go on and on and on right until the nth term at the end. I'll do the final three terms. So the final three terms are going to be a plus n minus 3d, and then the second final term is going to be a plus n minus 2d, and then the very final term is going to be a plus n minus 1d, like this. If you really want to, you can plug this into the formula un, where un is equal to a plus n minus 1d, where this is the first term, the second term, the third term, and this is all the way up to the nth term, like this. And you can see that this is the nth term here. This would be the n minus 1th term, this would be the n minus 2 second term, stuff like that. So this does make sense. So this is Sn, and I'm going to write out another Sn, so another Sn like this, but I'm going to write it in the opposite order. I'm going to start with this and I'm going to end with the first term here. This is, of course, it's still just Sn. This is the exact same thing, it's just a different order of writing it. So I'm going to write the last term first. It's going to be a plus n minus 1d here, and I'm going to write the second final term here, so it's going to be a plus n minus 2d here. I'm going to write the third final term here, so it's going to be a plus n minus 3d here, and this is going to go on and on and on until the third term here we'll write is a plus 2d. The second term is a plus d, and the first term is just a. So we've just written it in the opposite order, and what we're going to do is we're going to add these two together, these two Sn's together. So this is of course just going to be 2 Sn, as we've just added two Sn's together, but we're going to add them with this order, and we're going to add the terms like this. So we're going to add the terms where in the opposite order. So the first term is going to add to the final term, the second term is going to add to the second final term, and the third term is going to add to the third final term, and so on and so forth. And you will find that for every single term it gives out the same answer. It gives out 2a plus n minus 1d. You can see this very easily with here, because this is just a plus this is just going to be 2a here plus n minus 1d. This here is going to be a plus d plus a plus n minus 2d, so this is going to become 2a, and this is going to be 1 more, so it's going to be n minus 1, and this is the case for every single term. So every single one gives 2a plus n minus 1d, and this happens n many times because there are n terms. We have n terms in Sm, so there is going to be n many times of this. And then what we're just going to do is divide both sides by 2 here. We have a 2 here, divide both sides by 2 to give Sn is equal to n over 2 of 2a plus n minus 1 d here, which is what's required. Sn is equal to n over 2 of 2a plus n minus 1d. So again, the spec specifically says you need to know how to do this, and because it's quite an odd technique, I would learn how to do it. Now, the spec also specifically says that you could be asked to prove the sum of the first n natural numbers. If you don't know what natural numbers are, they are all the positive integers, so 1, 2, 3, etc. It's sometimes given this n symbol like this in exam questions. Now, there are a fair few questions like this, normally for a specific set of numbers, and there's a question at the end of the video like this as well. This one here is more general, and it's what the spec actually says, to prove that the sum of the first n natural numbers. Now, the book, in my opinion, the textbook, is a bit weird for its example. It uses a similar proof to before with proving the formula for Sn, a similar method to that. The way I would do this is just use the formula for Sn given in the formula booklet. We're not proving this formula for Sn like the last question, so therefore we can just use this formula here. There's questions similar to this in the old spec, such as the question at the end of this video, and the mark schemes also use the method that I've just said and not the one that the book has used of proving it a bit more from first principles about without using the formula for Sn. So if I was you, I would just do it like this with using the formula. So the sequence is the sum of the first n natural numbers, so it's going to be 1 plus 2 plus 3 plus 4. This is going to go on and on and on up to n, whatever n is for the last natural number. And therefore we can see here that we need to find a, d and n. Well, a is just going to be 1 because the first term is 1 because the first natural number is 1, and d is also going to be 1 because it goes up by plus 1 each time, and then n is just going to be n because it's the sum of the first n natural numbers, and we can use the value of n in our final answer here, and therefore we can just use the formula for Sn here. So we can say that Sn is equal to, so n is just equal to n, so it's going to be n over 2 of 2, and then a is 1, plus, and then it's still n minus 1 times d, which is just 1 like this. We can do a lot of simplifying here, so it's going to be n over 2, and then 2 times 1 is just 2, and then this 1 here we can kind of just ignore, so it's just going to be plus n minus 1 here. We can get rid of these brackets here and just write it like this, which we can write as n over 2 of 2 minus 1 is 1, so it's going to be 1 plus n like this, which we can simplify to n over 2, so n over 2 times 1 is that, and then n times n over 2 is n squared over 2 if we expand the brackets. So Sn is equal to, I'm going to write it in the opposite order as the question just desires, n squared over 2 plus n over 2. And then that's the final answer. So again, I would do it like this by just writing out the sequence like this and using the formula for Sn. So Sn, we've proved that it's n squared over 2 plus n over 2. So here's a question on arithmetic sequences series. I've given you the formula for Sn because in an exam you'd be given it in the formula booklet, so you don't need to remember it, and you can just look it up in there. So pause the video, have a go, and I'll go through the answers in about 5 seconds. Okay, so for part A, we need to calculate the sum of all the even numbers from 2 to 100, so it's going to make this sequence here. And this is similar to the last example, where we can just figure it out using A, D, and N, and using this formula here. So A is the first term, and we can see that this is just going to be 2, and then D, we can see that each time, because it's even numbers, each time it goes up by plus 2, so it goes up by plus 2 each time, so therefore D is just going to be 2, and then n is going to be equal to 50. Normally it would be 100 if we were doing the natural numbers from 1 to 100, but as we're only doing the even numbers, there's only going to be half as many, so therefore n is going to be equal to 50 instead. And then what we can just do is plug it into this formula here, so it's going to be S50 as n is equal to 50. S50 is equal to 50 over 2, and then 2 times 2 plus, and then it's going to be 50 minus 1 times d, which is 2, like this. And if you put this into a calculator, it's equal to 2550. So the sum of all the even numbers from 2 to 100 is equal to 2550, and that's the final answer. So for part B, part I, we need to find in terms of k an expression for the number of terms in the series. And the key to this is realising that they have given us the final term. And what we can do is realise that this is the first term, this is the second term, this is the third term. And whatever term this is here, this is going to be the final term. So therefore this is going to be equal to the number of terms in the series. If this is the final term, whatever n is here, what nth term it is, this is going to be equal to the number of terms in the series as this is the final term. So we can use the formula un is equal to a plus n minus 1d. This isn't given to you in the formula booklet, so you will need to remember this. And then equal this to 100 for this, because we want to find this term. Find a and d using this sequence here. Rearrange in order to find n for this value, and then that would be equal to the number of terms. So for this sequence, a is equal to k. It says that we can find it in terms of k. D is also equal to k, because you can see that the difference between each term is plus k. K plus k is equal to 2k, 2k plus k is equal to 3k, so it goes up by k each time. N is what we want to find, so we're just going to call this n, and then we're going to equal this to 100, so it's going to be 100 is equal to, and then it's going to be a, which is k, plus n minus 1, and then d is also k, like this, and then we're going to rearrange in order to find n, to find what nth term this is, and that's going to be equal to the number of terms in the series. So we can rearrange this just quickly to a bit of an easier format. 100 is equal to k plus k of n minus 1 like this, and we can expand this bracket to get 100 is equal to k plus kn minus k. Then these two k's just cancel out to give 100 is equal to kn. So therefore, if we divide both sides by k, it's going to be n is equal to 100 over k. So n is equal to 100 over k, and we're told that k is a factor of 100. So that means that when we do this, k is going to be something like 5 or 4 or something like that. So whenever we do 100 divided by k, it's going to be an integer. It's going to be a whole number. So therefore, this is a valid solution because n will therefore be a whole number, and therefore it will be a term in the sequence. And then therefore, this is going to be the number of terms in the series. There is going to be 100 over k terms, as this is the final term in the series. So this is the final answer. So for b part II, we need to show that the sum of the series is this here. So therefore we need to use Sn up here and sub in the values of n, a and d. We know that n is equal to 100 over k, because we figured out before it's a number of terms in the series. We also figured out before that the first term a is equal to k and d is also equal to k. So we're going to sub these values into Sn. So it's going to be Sn, technically it should be S100 over k, but that's a bit messy, so we'll just write it as Sn is equal to n over 2, so it's going to be 100 over k over 2. So a more neat way of writing this is 100 over k divided by 2 like this. And it's going to be 2a, so it's going to be 2k plus n minus 1, so it's going to be 100 over k minus 1 times d, which is equal to k like this. And this is equal to, so 100 over k divided by 2 can simplify to 50 over k, and then it's going to be 2k, and another way of writing this is k of 100 over k minus 1, and then we're going to expand this bracket here, so it's going to be 50 over k of 2k plus, and then k times 100 over k is just going to be 100, and then k times minus 1 is going to be minus k like this, and this is going to be equal to 50 over k. 2k minus k is equal to k, and then it's going to be plus 100 like this, and then this is going to be equal to, if we expand the bracket, 50 over k times k is going to be equal to 50, and then it's going to be 100 times 50 over k, so it's going to be 50 times 100, which is equal to 5,000 over k. So the sum of the series is 50 plus 5,000 over k, which is what we've got. So for part C, we need to find, again in terms of k, the 50th term of the arithmetic sequence, and then we've got this here in terms of k. And the way that we do this is just realizing that we can just use the formula un is equal to a plus n minus 1 d, like this, where we can find the values of a and d, and we need to find the 50th term, so therefore n is going to be equal to 50. So therefore we just sub in the values, and we'll find in terms of k the 50th term of the arithmetic sequence. We don't need to find the exact value, it's going to be in terms of k like this. So a is going to be equal to the first term, so this is just going to be 2k plus 1, and then d is going to be the difference between each term, which we can easily figure out because it's just going to be the difference between each term. So it's going to be 4k plus 4, and then minus this term here, so 2k plus 1, and this is going to be equal to 4k plus 4, expand the brackets to minus 2k minus 1, which is going to be equal to 2k plus 3 like this. So this is going to be d, as this is going to be the constant difference between each term. It's going to go up like this, 2k plus 3. If we really wanted to confirm that it goes up by this each time, we can find the difference between these terms as well. So it's going to be 6k plus 7 minus 4k plus 4, expand the brackets to 6k plus 7 minus 4k minus 4, which is equal to 2k plus 3, which is the exact same difference. It's a constant difference each time. So d is equal to 2k plus 3, and then n, as we want to find the 50th term, n is going to be equal to 50. So u50, as we're finding the 50th term, n is equal to 50, is going to be equal to a, which is 2k plus 1, plus, and then n minus 1, so it's going to be 50 minus 1, so it's going to be 49, and then d is equal to 2k plus 3. And then we can expand the brackets because we need to find it, the answer in the simplest form. So this is going to be equal to 2k plus 1 plus, and then 49 times 2 is going to be 98k, and then 3 times 49 is going to be equal to 147. So this is going to be equal to, if we just simplify, 2k plus 98k is going to be 100k, and then 1 plus 147 is going to be 148. So U50 is going to be equal to 100k plus 148, and that's going to be the final answer in the simplest form.